Hello everyone. So now we will see this question where there are 6 questions written. These two are the circuits, circuit A and circuit B. You have to draw the output waveform. You have to you should tell the slope of output at t equals to 0. Then output current waveform, again the slope, time constant, and poles and 0. Okay. So now first see the circuit A. So 0 and 5. Okay. I know most of you already know about it, but let's see it first. Okay, so at t equals to 0, capacitor is uncharged, so your V naught is 0, right? And at t equals to infinity, capacitor will be fully charged, so your V naught equals to 5 volt. So your output waveform will look something like this. V naught and T. 0 to 5 volt. Okay, so that's one way of explaining it. Okay, now I will tell you one another way. So what you will say, at t equals to 0, the capacitor is uncharged, so the current is V by R. This is uncharged, so this is at 0 potential, so the current would be VI by R. Now this VI by R current, here we have some capacitor. This acts as a short circuit, but it is not short circuited in reality. This is acting as a short circuit. Okay, so here we have a capacitor, here we have R, and there we have some V by R current. So this V by R current is charging the capacitor. Now this V by R is charging the capacitor. The value is 5 by R. Okay, 5 by R. Okay, now let us assume the capacitor is charged to some 1 volt. At t equals to t1, V naught is 1 volt. Now what is the current? 4 by R, right? This is 5 by R, now 4 by R. So first we had current 5 by R, then we were going to 4 by R, then we were going to slowly 3 by R. So slowly the current is getting reduced. Okay, slowly the current is getting reduced. If the current is getting reduced, then the speed of charging is also getting reduced. Okay, first we had 5 by R current, 4 by R, 3 by R. The speed of charging is slowly getting reduced. That's why we have an exponential waveform. Okay, and slowly it gets to charge to 5 volt. First it is charged to 1, then 2, then 3, then 4, and slowly it gets to charge to 5 volt. Why only 5 volt? When Because when Vc equals to V naught equals to 5 volt. So this is your circuit. Here we have 5 volt, and at the input as well we have 5 volt, and this is R. So what is the current? IR equals to IC, that is equals to 0 ampere, right? Because here we have 5, here we have also 5. So the current is 0 ampere. That means no current flow in capacitor. So no further charging or discharging. Okay, that means steady state. So after that there will be no charging and discharging. So what you can say is, first there is no voltage, first there is no charge across the capacitor, so the initial current is 5 by R. Then slowly the capacitor starts charging and the value of current starts reducing. So slowly the capacitor current starts, capacitor voltage capacitor starts charging, then the voltage of capacitor gets increased. Okay, so then it increased to 0 to 5 volt at steady state. At steady state, because capacitor is having 5 volt, there will be no current flowing through the capacitor. So there will be no further charging or discharging. That means we have reached the steady state. So that's your output waveform. So that's the answer of first question. Okay. Now talking about the second one, slope of output voltage at t equals to 0. Okay. So what you can write output voltage? V naught equals to Vc equals to 1 by C integration I dot dt. Right. This is the output voltage. So the slope will be dV naught by dt equals to I by C at t equals to 0. I at t equals to 0. What is I at t equals to 0? That is V by R. So the slope at t equals to 0 would be dV naught by dt at t equals to 0 would be. You have to go by the simple approach. Okay, you don't need to apply any equations that voltage, this equation. Some of you must have will apply this equation and then simply differentiate it and then put t equals to 0. Like people will differentiate it first. V into e to the power minus t upon tau into upon tau, then put t equals to 0. So it would become V by RC only. So that you shouldn't do. Okay, that's not a correct approach. The answer is right, but the approach is wrong. The interviewer will see this approach. Okay, so that's how you should tell. Your dV naught by dt at t equals to 0 is V by RC. Simply write the voltage equation of capacitor, then simply differentiate it. Okay, so this was the voltage waveform, and I have already explained about the current waveform only. So the current waveform would be answer 3. Let me draw the circuit once again. RC V naught I naught. Okay, so the current initially is V by R and slowly it starts reducing. Okay, so this is T and this is I naught. Okay, from V by R to 0. Okay, V by R, then the capacitor charge to 5 volt, then there is no current. So from V by R to 0 it reduces. It reduces. Okay, now talking about the slope. So for slope, what you can do? For slope, if you do like this, like dv naught d v naught equals to 1 by c integration I dot dt, then you have to differentiate it. Dv naught by dt equals to I by c. Now you need to find di naught by dt. For answer 4, you need to find di naught by dt, right? So what you will do? You will differentiate it once again, right? But now you don't know this value, right? You don't know this value, so you can't go by this approach. Okay, so now what you will do? Now you will write the simple KCL KVL equation. Simple KCL equation in this. Okay. Sorry, KVL equation. V equals to I into R plus V equals to I into R plus V naught. Okay. This is V naught. V equals to I into R plus V naught. Now simply differentiate it. dV by dt d I naught, because the I naught current is this I naught current is flowing through this resistance as well. Okay, so V equals to I naught into R plus V naught, d I naught by dt plus dV naught by dt. Now this will be 0 because V is constant, constant input voltage. Okay, so this will be 0. 0 equals to d I naught by dt. And what was this di naught by dt into r, and what was this value v by rc, right? dv naught by dt at t equals to 0. We are talking about at t equals to 0, at t equals to 0. So this uh, sorry, so this value at t equals to 0 was v by rc, because we already concluded it here. dv naught by dt at t equals to 0 is v by rc. So this is v by rc only. So di naught by dt at t equals to 0 is v by r square c minus, okay, minus of v by r square c. Okay, so that's your answer 4. Okay, so what you did here, you just simply wrote the KVL equation, simple KVL equation. You just wrote the KVL equation, and from there you could simply conclude it that di naught by dt is minus v by rc. So for writing the di naught by dt, you first need to know what is the value of dv naught by dt. Okay, and now answer 5. What is the time constant? This was your circuit, r into c. This is v naught, this is vi. What you will do, you will simply short circuit this, and what you will see, the equivalent resistance across capacitor. Time constant would be R equivalent into C equivalent. So R equivalent is R, C equivalent is C. So time constant is RC. Okay, time constant is RC. And what was the last question? Pole and zero. Yeah. So answer 6 now. Answer 6. What is the transfer function? V naught S by V in S. 1 upon CS upon 1 upon CS plus R. So it would be 1 upon RCS plus 1. So the pole is 1 by RC, and the 0 is no 0. Okay, there is no 0. This is the pole equals to 1 by RC. So that's it about the first circuit A. Okay, so this was about the first circuit. Okay, now you could see one more thing here. You just short circuited the capacitor at t equals to 0, right? At t equals to 0, you short circuited the capacitor, right? Because of 0 potential. And also what you can do, at t equals to 0, what is the frequency content? At t equals to 0, the frequency content is infinity, right? At t equals to 0, frequency content was infinity, because we had this tap. So if frequency content is infinity, what is 1 by omega c, 1 by j omega c, that is zc, that would be 0. So the impedance provided by capacitor is 0. So now we can short circuit this, right? At t equals to 0, we have infinite frequency content, and because of infinite frequency content, the impedance provided by the capacitor is 0, and because of that, we can short circuit this. Okay, now moving on to circuit B. So this was your circuit B. R V naught. This is V in. This is C. Initially, capacitor at t equals to 0, capacitor is short circuit. V naught is Vi. At t equals to infinity, capacitor is open circuited, and V naught equals to 0. Your output waveform So from Vi2 we will go to 0. Okay, so this is your, I should write not Vi, I should write it as V. Okay, because it will be some value from 0 to, so from V to 0 we will go. Or what you can say, at t equals to 0 capacitor is open circuited, so we have current V by R. At t equals to 0 we have current V by R, and because of V by R current the capacitor slowly starts charging in this direction, and it's charge, and at steady state it reaches to 5 volt. Okay, if we have this 5 volt here, at steady state it reaches to 5 volt, and because at steady state is it reaches to 5 volt, then the v node goes 5 minus 5 0. Okay, and then the current becomes 0 as well, and because the current is 0 there will be no further charging or discharging in the capacitor, and we reach the steady state. Okay, so that's how you can write. And now for, now the second question, the slope of output. Okay, so for slope of output what you can do, so what you can do, again apply the answer 2, again apply the KVL equation here. So like what also you can think, you can think V naught equals to I naught into R. Okay, so your dV naught by dt would be di naught by dt into R, but now you don't know this value. So actually you know, you need to know this value, but now you don't know this value, you can't apply this. So what you will do, you will simply apply KVL equation. Okay, so V equals to V equals to 1 by C integration I dot dt plus V naught I naught by dt. So differentiating it, dv naught dv by dt equals to I by C plus dv naught by dt. So at t equals to 0, this will be 0 because constant, and this is I naught at t equals to 0 by C plus dv naught by dt at t equals to 0, that we need to find. So dv naught by dt at t equals to 0 would be, what is the current at t equals to 0? It was V by R, right? I told you here this will be short circuited, so current would be V by R. Okay, so it would be V by RC, but minus sign, minus of V by RC. So this is the slope of output voltage at t equals to 0. Okay, now the third waveform. Now we will draw the output waveform, output current waveform. So it would be, initially we had V naught by R current. Initially we had V naught by R current, and slowly it goes to I naught T, you can write, and slowly it goes to 0. From V naught by R it goes to 0. Okay, so this is your answer 3, and answer 4 you need to find d I naught by dt, right? So what you can do now, you know V naught equals to I naught into R, right? So your dV naught by dt would be di naught by dt into R. So at t equals to 0, at t equals to 0, your di naught by dt at t equals to 0 would be dv naught by dt. What is dv naught by dt at t equals to 0? What is dv naught? Minus v by rc. So it would be minus v by r square c, because this r would come here. So minus v by r square c. So that is the answer of fourth question. This is the answer of third question. And for answer 5, what is the time constant here? Again the time constant is rc only, because the equivalent resistance, because this will be shorted, right? This is K R and this is C. The equivalent capacitance or the equivalent resistance across the capacitor is R. So time constant is RC only. And what is the transfer function here? V naught S by V in S is SRC upon 1 plus SRC, right? So your 0 is at 0, and your pole is at 1 by RC, right? Your pole is at 1 by RC and your 0 is at 0. So from here you can see this. Okay, so that's it about the first video. So what did we see here? First, we in the last video we saw what is step function. Then we saw these six equation: output waveform, slope of output at t equals to 0, output current waveform, slope of output current at t equals to 0, then the time constant of the circuit, and then the pole 0. This was one very simple question, and this is most of the time this is the first interview question. Okay, this is the first interview question, and the like you shouldn't go by this approach at t equals to 0, v naught is 0, then this will be fully charged. You should tell the interviewer by this approach. Initially the current is 5 by r, then the slowly the capacitor starts charging and the current goes low, and because the current goes low the speed of charging gets low, so exponentially it will rise to 0 to 5 volt. At 5 volt there will be no current flowing through the capacitor, so there will be no further charging and discharging, and we will reach the steady state. That's how you should tell the interviewer. Then if you have ask about the output voltage, slope of output voltage at t equals to 0, then you shouldn't go by these equation. You should simply write the voltage equation and then simply differentiate it. Okay, then the time constant and all these stuffs. Okay, then the same stuff in the second question. Okay, so that's it for the first video. Okay, thank you.